everybody. Gonna get class started here. It is 11:20. Welcome. I hope you guys are doing well and staying dry and warm. Just a little heads up. We're getting really close to the end of this trimester. So the end of the trimester is March 12th. There is no school that day. So our last day is going to be March 11th. Okay. So just a couple of things that I want to point out to you really quickly. Make sure that if you have missing assignments that you ask for an extension to get those done and get those done quickly. I'm going to be teaching you guys. We're going to be diving into Conics. Conics is going to be our last topic. So get really excited for that. So our first one we're going to talk about is parabolas. But what I should talk about first is what the heck is a conic and why do we learn about them, right? So also, can you guys remind me before we leave today, you can't leave today without me showing you guys how to graph parabolas in WebAssign. It's confusing. So you need to stick around so I can help you out with how to do that. Yeah, absolutely. There will be a final. Yeah. Just like last semester, guys, or trimester, just like last trimester. Okay. We'll probably use that last day to like we won't have class that last day and you guys can work on your final. I think that's fair. So that means we'll have one day of review and then one day where you guys can just take the final. Okay. All right. So what is a conic? Now, it's really important. There's actually three different ways of thinking of conics. Okay. There's the way that that the Greeks, the ancient Greeks, looked at conics. There is the algebraic way of looking at conics, which it's a mixture of geometry and algebra. So you have to remember algebra came from the Persians in the Middle East. So when you take a look at it this way, like the visual way, this is like a classic Euclidean geometry. Okay, but then we're also going to look at it from an analytical perspective, which is the algebra and geometry. And then we're also going to look at it in terms of locus. And so I just really wanted to show you all three before we get started. So just so the classic geometry thinks of it is that if you have two cones on tippy toe on each other, right, two inverted cones. So a conic is a cone section. So if you cut it like this, you get a circle. If you cut it like this at an angle, you get an ellipse. If you cut it like this, you get a parabola. And a parabola is what we're going to be talking about today. And don't call it parabola, okay? Because that's just a joke. So don't call it parabolas. Sometimes Dewey makes bad jokes about parabolas. Okay, so a parabola, right? And then a hyperbola is like this, okay? Like that. And then there's also, these are called degenerate conics. Again, not a word you need to know, right? We have a point, a line, and two intersecting lines, okay? So that's conics as like a geometric thing. But that doesn't do too much for us, though it is kind of cool. So what we're going to focus on, and I know I'm just showing you the book. It's just, don't put this in your notes because it's in the book. But this right here is the algebraic way of doing it. And so this is a polynomial, right? So if we were going to be doing number theory, if we're going to be doing discrete mathematics and stuff like that, the algebraic is going to be really useful, and we're going to dabble a little bit into the pure mathematical definition. But as you can see, like, what's easier on your eye, this polynomial or this cut? And then there's also the locus, right? And a locus is just a series of important points, and that's how we do this, right? And so if you think about a circle, what's the locus for a circle? It's the center, the radius, and then all of the points around that. So that's an example of a locus. Okay, so that's what we're going to be doing. Yeah, it should remind you of geometry because what we're getting into is we're getting into analytical geometry. We're taking geometry and we're adding in algebra to do all of that. And that's really how geometry is used nowadays. Okay, so to do this, let's take a look at what is a parabola. Okay, now you guys have learned parabolas as quadratics, right? So a quadratic is the graph of x squared. Okay, but a parabola is, though a quadratic can be a parabola is not necessarily a quadratic. Crazy, right? Okay, so what's going to happen here is that This is my coordinate system. And how we define a parabola. So let's just write down the definition first. So the definition of a parabola, so a parabola, okay, is the set of all points. And remember, set in math just means collection. So when I say a parabola is the set, it's the collection of all points in a plane that are equidistant. Right? So that root word means equal. So equidistant means the same distance. So equidistant means same distance from the directrix. So from the directrix, right? Direct and then trix, like tricks are for kids, directrix, and a fixed point. Point not on that line. Gosh, now that is a mouthful, right? So you can see why you learn quadratics in Algebra 1 and 2 instead of learning about parabolas. Okay, so a parabola is the set of all points, x, y, in a plane that are equidistant from the directrix and a fixed point not on the directrix. Okay, so what the heck does that mean? Okay, so if I were to draw a basic parabola, it would look like this. Okay, and so what's going on here is that I'm going to add a couple of points. So here's point 1, here's point 2. Okay, and let's say point 2 is some x, y. Okay, what we're saying here is that we're going to have a directrix Okay, so that is a line, and then a point not on that line, and this point is called the focus. And it's called a focus for a reason, and I'll talk about that today before we leave. Okay, so that's going to be a focus. And what's important about this is this distance right here from our vertex, right, to that is called P. And this is called the direct length. Oh no, I messed it up. What's it called? You can tell I never use this language ever in my entire life. What does your book call it? It's called the directed distance. Okay, there you go. Whew, never used that in my entire life. This is called the directed distance. Now, I'm about to do something. I'm about to write something down. And if you just write it down, you're going to be so confused. So I want you guys to know that this distance right here is P. You guys okay with that? So the distance from the vertex to the focus is called P. Now, this distance right here is also P. But we don't call it P. Okay, and that's going to be really important because if P is positive, that means we're going up. If P is negative, that means we're going down. So this distance from the vertex to the directrix is also P, but we don't define it as P. P is from the vertex to the focus. Okay? Then, if we get to the definition, what we're saying is that this distance, D1, is the same as this distance. And that this distance, you can see I didn't do this very well, is the same as this distance. Okay, so these two distances are the same, and these two distances are the same. That's the definition of a parabola. Oops, sorry, the directrix. I was wrong there. Sorry about that. Okay, so this distance and this distance are going to be the same. So obviously I didn't draw this very well. Okay, but they're equidistant. So the distance from the directrix to the point is the same as the distance from the point to the focus. Okay, that is the definition of a parabola, which isn't the definition of a quadratic. A quadratic is just something squared. Okay, it's just a polynomial that's of the second order. Okay, now that's all really complicated, right? So I'm going to draw another one. I'm going to draw another one of these just below. I don't think the book does a really good job of this. Okay, and I'm going to draw, so here's my vertex. Okay, so this is my vertex. And then I have a focus, and that is P away. Okay. And then I'm going to have a directrix. Okay. Now, the equation for the directrix is going to be, so let's do this. So let's say my vertex is HK, because that's the symbols we use for a circle, right? The center of a circle is HK, right? So if the focus is P above, notice how the X is the same and the Y is P more. So the focus would be H and then K plus P. Do you guys see how that would be the coordinates? So you would take your vertex and you would just go P up. P up. All right, and then to get down here, your directrix is going to be the same Y as my K, but P down. So this would be K minus P. Okay, so again, we defined P as being the distance from the vertex to the focus, but to go down, the directrix is just going to be that Y value minus P. So you go up P to get your focus, you go down the other direction to get your directrix. Okay. All right. So with that, we have some formulas. So this is the standard conic formula. So this is the standard conic formula for a parabola. Okay. So now there's two types of parabolas you can have. You can have ones that are functions that are either smiling or sad, or you can have ones going to the right, or you can have ones going to the left. So because you can have them going up, down, left, right, there's two general equations. So these equations are, we have x minus h quantity squared. So if the x is squared, that's going to be looking like this, equals 4p y minus k. Okay. And just to be clear here, right, this is going up or down. Okay, so this picture is going up or down. Okay, and the directrix equals k minus, oh, sorry, it should be y equals k minus p. Okay, so hk is your vertex, right? HK is your vertex. This form and P is the distance from your vertex to your focus. This equation is either going opening up or down, and your directrix is K minus P. You don't really have to worry too much about the directrix. So when I took math, the directrix was a really big deal. This book doesn't make it a big deal, so don't worry too much about the directrix. Okay. The other equation is we're going to switch X and Y. So it's going to be y minus k squared, and that's going to be 4p x minus h. Okay, so this is for opening to the right or opening to the left. Okay, and the directrix is going to be y, sorry, oops, it's going to be x because it's going to be vertical. Y equals h minus p. Okay, and I'll show you examples of these in just a little bit. But this is what you need to know, right? Because everything is online, everything is open notes. You just have to have access to these equations. Okay, if we didn't have access to notes, I would derive all of these for you and tell you how to know them instead of memorize them. Okay, but since we're online, you really just need able to look them up and to do them. Okay. The book also gives examples of what it would be like if it's at the origin. What a waste of time. Don't do that. If h and k are 0, just plug in 0 for h and k and figure it out. Okay, so what I want to do is just show you all of these things. Okay, because with conics, at this point, you guys are entering the math area of where you just need to think about it and be clever. If you try to, and you guys were getting to the point in math where I hope you guys realize there's so much math that there's no way that you can even see all the math, let alone memorize it. Okay, so this is an example, right, of a parabola opening up. Notice how the vertex is at hk. You don't need to take notes on this. Don't take notes on this. Just look and see and make sure you understand. So if the vertex is hk, notice how the focus is up p. Okay, and the p is greater than 0. So p is greater than 0, so it's up p. Okay, the directrix is down p from my y. Okay, the equation we would use is the x minus h squared version because it looks like a quadratic, right? This is a quadratic. Okay, that's what you need to know. That's what you need to be able to take away from that. This next one, okay, we have a parabola opening down. Now notice the p-value here will be negative, right? Does that make sense, guys? I just want to make sure that makes sense. So we define our p as being from the vertex to the focus. Because the vertex is above it, we're going to have to subtract p, right? So to get to the focus, p is already going to be negative. So what they do is they just always say you add p, right? So if p is negative, then you're adding a negative. That's what it means there. So the reason why they do plus is because it's not inversely proportional. It's directly proportional. So if p is negative, you're just adding a negative, you're going down. Okay, now notice if I again, see how they always just keep the directrix as negative? They're just saying the directrix is opposite of your focus. That's what the negative means there. So you follow your p to the focus, and then the directrix is the opposite direction, whether that's positive or negative. Okay, so that's what they're doing here, and that can be confusing for some people. Okay, your vertex is still hk. You use the p-value to find your focus. Guys, in your homework, we're going to be asking you to find the focus and the directrix. Okay, here's another one. So this case, this isn't a function. It's opening to the right. Again, the vertex is hk. My p-value is greater than 0, so that's going to be moving me to the right. Okay, now what's really important here is this is not a quadratic. So we're going to be using the y squared version. Okay, and that's how you can tell, right? A quadratic is x squared. So it looks like a quadratic, it's x squared. If it doesn't look like a quadratic, it's y squared. Okay, it's not a function. Okay, how are we doing so far? And do you guys see how if it's on the x, we add p to the x value, right? So if it's opening to the right, we add it to the x value. So obviously this is going to get really confusing if we don't have a picture, right? And I'll show you guys how to do that. Okay, and this last one, because I'm running out of time, right? It's opening to the left, so the p will be negative. So when I add that p, I'm going to be going to the left, okay? And then again, I'm using this. Okay, so thank you for not taking notes on that. I just wanted to show you really quickly. All right, so what the heck are we going to do with all of this? Okay, let's do some problems. Let's do some problems. Oops, let's zoom in a little bit. Okay, remember, ask questions, and if I'm going too fast, throw a shoe at me. Okay, so we're going to, so here's example uno. We're going to find the, quote, standard. I hate this. So they call it the standard form, but it's really the standard conic form of the parabola given that the vertex is 3, 2, and the focus is 1, 2. Okay, so this is going to be the first thing we're going to do. So the first thing that we should do, because we have two equations, right, is we need to figure, is this opening up, down, left, or right? So if we take a look at our focus, notice how our focus has the same y value. So if it has the same y value, that means it's opening up left to right. And these are just thinking problems. And you might, what you might do to do this is you might go like this. Okay, 1, 2, 3, 1, 2. Okay, there's my vertex. And then my focus is at 1, 2. Oh, so which way am I opening up? I'm opening up this way. And do you guys see how you can just do a little sketch like that? So I know I'm opening up to the left because the focus is going to be inside my parabola. And again, I'll get to why it's called the focus in a little bit. It has to do with satellite dishes. Okay, if you have satellite TV, then you know that you have a parabola dish with a little focal point in the middle, little mic, if you might say. Okay, we'll talk about that, why that is. So to do this, I know I'm going to be using this form. Okay, so the first step there is I sketched a little picture, and then it helped me see, hey, I'm going to be using this form. So let's see what we have. We have, so this is my H, that's my K. Good to go. So we have our H and our K, but we don't have P. So remember, P is defined as the distance between your vertex and your focus. Okay? So in this case, right, it's going to be a change in x, right? So this case is a change in x only. So what's my change in x, right, from 3 to 1? My P here is going to be, I don't know why it made it red. My P is red. Is that good? P is going to be, is immature hour, is going to be -2. Because the focus, and that's an F, the focus is to the left 2 of my vertex. Now, you guys haven't said anything so far. Am I doing an okay job explaining this? Okay, because, yeah, we're not doing anything too crazy yet. So, that's it. That's all you need. You need this, and you need this. So, my answer then is y minus 2, quantity squared, right? Where did I get the 2? The 2 is my k. Equals 4 times -2, and then x minus 3. And then we're just going to clean that up. 4 times -2 is -8. Okay. So starting off nice and easy there. Any questions about that? Sorry, I feel rushed for time, and so my anxiety is going up. So I'm taking a deep breath and just remembering that we're going to be okay. Okay. So let's do some more with that. So this is an idea. So given the vertex and focus, we can write the standard form. So see how this is the locus version of conics, right? Given just a couple of points, we can write the equation. So given 2 points, I can write the equation for a parabola, which is really awesome because with quadratics, you can't do that. Okay, cool, right? All right. So let's do another one. You guys are like, yeah, Kraft, totally cool, whatever. All right, so let's do another one. So in this case, let's do one more. We're just going to do one more. So let's say write the equation given, what do we have? So my vertex is going to be 2, 1, and my focus is going to be 2, 4. In fact, why don't you guys try this? You try that. So write the equation if the vertex is 2, 1 and the focus is 2, 4. Give that a shot. Here, I'm going to give you guys a minute 30 to do that. All right, let's take a look at this. If you guys have questions, please ask. I want to make sure you guys feel confident about this. So the first thing I'm going to do, and I think it's going to be just really easy, just sketch these 2 points really quickly. So the first one is right 2 up 1. That's my vertex. And then my focus is right 2 up 4. Okay. So there's my focus. So then I know I'm going like this. Okay, so I'm going up. So because I don't have these, you guys like listening to me talk? That's really nice. Thank you. I appreciate that. And thank you. That was a joke. Thank you. I didn't know my mic was off. All I was saying was I gave my social security number and my bank account numbers. So too bad that didn't work. But what I was saying is that just start off by graphing your vertex and your focus so you know which way you're going. And then I was going to say, I actually don't have those equations memorized, so I'm going to look them up. So what do we got here? So it's opening up. That's a normal quadratic. So that's going to be x minus h quantity squared equals 4p times y minus k, like that. Okay? So we need to, so I have my vertex, so I have my h and my k, so we just need to find my p. So my, I'm so immature. To find my p, right, that's going to be the distance between my vertex and my focal point. So I can see that's my y. So if I start at 1, how far is it to 4? That's going to be 3. Okay, so my p equals 3. And I have my h and my k. So then all I'm going to do is I'm going to go x. My h is 2. So minus 2. And then 4p. 4 times 3 is 12. And then y minus 1. Like that. Okay. All right. So we did 2 examples of that. So shoot, we get out at 12:10. So I have... Okay, so we have enough time. We're going to learn one other thing today with this, and then I have to show you the WebAssign. I have to show you the WebAssign, so I have to have time to do that. Okay, so the next thing is, what if we're given the equation, can you find everything? Okay, so here's example 3. So let's say we have y equals negative 1/2 x squared minus x plus 1/2. And we want to find the vertex, the focus, and the directrix. Okay. I always order my tricks direct, because tricks aren't just for kids. They just lie to make them cool. It's like, yeah, I'm not a kid. I eat tricks. Oh wait, I am a kid because I eat tricks. All right. What's wrong? Right? This is in standard form for a quadratic. It's not in standard form for a conic. So the first thing we're going to have to do is we're going to have to get this to standard conic form. Okay? So to do that, what I'm going to do is I want to get my x's on one side and I want to get my y's on the other side, right? So you can see too, see how the squareds with the x, we know it's either going to be opening up or down. With the negative here, it's going to be opening down. So how do I do this? Well, I want to be able to factor this out. Oh, we're going to have to complete the square. I forgot. So if you guys don't remember how to complete the square, right? Remember, when we do this, do you guys see how this is vertex form? The last time you guys learned how to complete the square was when getting to vertex form. So what we're going to want to do is we're going to want to get the x's by themselves, and then everything else over to the y, and then we're going to want to complete the square. Okay? And if you guys forgot how to do the complete the square, I'll help you out. So the first thing that I'm just going to do here, because it's going to help completing the square out, is I'm going to multiply both sides by 2. Okay? So I get 2y equals negative x squared minus 2x plus 1. Like that. Okay. Shoot. You know what I just realized? Having the negative there is going to be not fun. So let's go ahead. I'm going to multiply by negative 1 really quick. So let's go negative 2y equals x squared plus 2x minus 1. There we go. Okay. Now, this isn't a perfect square. Do you guys see this? This isn't a perfect square. So I want to make it a perfect square. So to make it a perfect square, right? So again, here's the problem. This isn't a perfect square. I want to break it. See how I have x minus 2 squared? I want to be able to make this a perfect square or a difference of squares. And it's not right now. So what I'm going to do is I'm going to add 1 to both sides. And the reason why I'm doing this is because I want to set up the right side. Do you see how this is a perfect square? I mean, this is a difference of squares, sorry. I either want to get a perfect square or a difference of square. Now, completing the square will always give me a perfect square. Okay, so I want to get a perfect square. Oh my gosh, whatever. I want to get a perfect square. There we go. I'm thinking too much. I don't have time. Okay, to get a perfect square, right? So do you guys understand, right, that like this is like, okay, if I look at this, right, this is a difference of squares, but I can, like, a difference of squares can easily be a perfect square. I want to get a perfect square, and I want to get it with my term that has a squared. So if y was squared, I'd want to get the perfect square with the thing that has the squared in it. So to do this, what I'm going to do, right, do you guys remember the steps? You take half of your linear term, right, so that equals 1. And then I'm going to square it and add it to both sides. So you take half of the linear term and then add it squared to both sides. That's how you complete the square. Okay? you take half the linear term, and then you add it squared to both sides. Are you guys okay with that? Okay, you guys know this lesson is so weird because I don't know if you guys get this at all. All right, so if I do that, that's all you have to do to complete the square. So basically then what this turns out to be is this is x plus 1 squared, right? And that's my b term. Okay, that's it. Okay, and then this side, what do I end up getting? This side I end up getting negative 2y plus 2. So I can factor out a 2. So I get 2 times, do I want to keep that negative? Yeah, let's keep it positive. Okay. So what's the steps? I feel like no one's giving me feedback, so I don't know where we are. Okay, either you guys know how to complete the square and this makes sense, or you're totally lost, I guess. So all I did was I got my squared side by itself. Do you guys see how I got my squared side by itself? This wasn't a perfect square, so I removed it. So I just had the two terms with the side that has the square in it. You divide the linear term by 2, and you add that, what your result was, squared to both sides. Okay, that results you in a perfect square. And then you just keep going from there. So to get my answers now, I have to get, so my vertex. So remember from my equation, right? My equation here was, so this would be x minus h quantity squared, and then I'd have 4p y minus k. So my vertex is hk. So let's take a look. So it's always going to be backwards. So my hk here would be -1, and my k here is going to be +1, like that. Right? Because notice here in my thing it's negative, so that means opposite. So if it's -1, the opposite of -1 is 1. And here the opposite of 1 is -1. And then my focus. So to find my focus, I'm going to have to get p, right? So take a look here. So -2 equals 4p. So that's -1/2 equals p. So I know I'm going to be opening, how am I going to be opening? I know from looking at it that I'm going to be opening down, and my p is negative, right? So that means, let's take a look here. So if I had my vertex and I was opening down, so that means that my y, so I'm going to be y minus p. So 1 minus 1/2 is -1/2. So my focus is going to be at -1, -1/2. You guys see how I did that? So I did y minus p. So here's my y. So, this is going to be k minus p. Right? So if this point right here is hk, then this point down here is going to be k minus p. Okay? So that's my focus. And then my directrix is going to be, it's going to be the opposite direction. So in this case, it's going to be a y equals, and it's going to be k plus p. So my p is -1/2. No, sorry, it's going to be minus p, sorry. Because it's going to be higher, right? So minus and negative is higher. So it's going to be y equals, so my k was 1, so now it's going to be 1.5. And those are my answers. Now, we got out at 12:10, right? Can you guys hear me? Okay, 12:10. All right, let's do one more of these. let's do one more of these. Okay, now I have to, you cannot leave until I show you WebAssign. Okay. Okay, so we're going to write an equation. So what example is this? Is this 4? Okay, so we're going to given, okay, so what are we going to do? We're going to do given y equals negative 1/6 x squared plus 4x minus 2. Okay, now we're going to find all the same things again. So I just don't have time to write that down. So we're finding all the same things. We're going to find vertex. So right, we're going to find the vertex, the focus, the directrix. Sorry, I'm just abbreviating because we don't have time. So the first thing I want to do is I want to isolate my x term. So unfortunately I did x. Oh well, just it doesn't matter. So I'm going to start by multiplying both sides by -6. So I get -6y equals x squared plus 4x minus 2. Then you look, is this a perfect square? So it's not a perfect square. Okay, 2 times 2 is 4. 2 plus 2 is not -2. So I'm going to then take this and add 2 to both sides. So I end up getting 2 minus 6y equals x squared plus 4x, like that. So now we're going to make it a perfect square. Okay. So to do that, I'm going to take half of this. I'm going to call that my b. My b is going to be 2. Then I add b squared to both sides. 2 times 2 is 4. Like that. Okay. Am I going too fast? Are you guys doing okay? You know, sometimes it's just faster to, you can hit spacebar on your keyboard and your mic will turn on temporarily. So it's easier just to hold keyboard and be like, yes, it's going okay, than it is to type. Okay, just you guys would rather type. All right, you're weird. All right, so then I'm gonna have on this right side, I'm gonna complete the square, right? So it's gonna be x plus 2 quantity squared, right? All of that goes to this. Then here, I'm going to go 4 plus 2 is 6. So I have 6 minus 6y. So again, the numbers here really are working out for us. I can factor out a 6. Let's factor out a negative. So if I go -6, then I get y minus 1. And then I get x plus 2 quantity squared. And I just pulled out a -6 here so that it looks like the function that we had before. Right, so the function that we had before was 4p y minus k equals x minus h quantity squared. So if I want to find my vertex, am I going too slow? I mean too fast. Sorry guys, I teach Algebra 1 this year. I teach Algebra 1 Extended this year, and I teach geometry, so like I got my Algebra 1 kids were like, you're going too fast today, and my geometry kids are like, you're going too fast today. I'm going to slow down because I'm probably going too fast. Did I lose anybody? Do you guys have questions? I have about 7 minutes. I only need 3 to do the WebAssign thing. Okay. Right. So now, look, if you look, the OG equation, right? This is in quadratic form. Okay. So what we're going to do is, because we want to find the locus, right? And the locus are all the important parts. I want to be able to find the vertex, the focus, and the directrix. So I'm going to convert it into conic form. Now, to convert it into conic form, all we're doing is we're isolating the quadratic. See if it's a perfect square. If it's not a perfect square, make it a perfect square. And this is going to allow us to get to vertex form, so we can get our vertex. And then you just rewrite the other side to look like the function. Okay. So the vertex that we're going to have here is, remember, do you guys see how it's opposite of what it says in the equation? So my vertex is going to be HK, and it's going to be the opposite. So the opposite of positive 2 is negative 2. The opposite of negative 1 is 1. Okay. And then I'm going to use a little picture really quickly to figure out what's going on. So if I'm at negative 2, 1. There's my vertex. Now my P, let's find my P. My P is negative 6 equals 4P. So that's negative 6/4 P. Now you don't want to reduce here, because if you reduce, you're losing it. Does that make sense? So you don't want to I guess you could. Yeah, it's negative 3 halves. Negative 3 halves. Okay? So if it's negatives, that means that my focus is down here. So this is opening down. And that makes sense that it's opening down, because in my original equation, I had an A term that was negative. Okay? So then my focus, right? My focus here is going to be, my Y is changing, right? So if B is HK, then F is going to be K plus P. So my P is 6/4. Okay. So so that's going to be 1 plus 6/4. So I can't think right now. Forgive me for my lack of 1 plus negative 6 divided by 4. So it's negative 1/2. So it would be negative 2, negative 1/2. Okay, so that's how I did that. And then my directrix is going to be above. It's going to be the opposite direction. So if I added P here, then this is going to be K minus P. So I would take 1 minus negative. Can you guys see I'm just changing it to a minus? So then I get 2.5. So this is Y equals 2.5. Okay, so I only have 2 minutes left. Does anybody have any questions with that before I show you WebAssign? Okay, again, you guys can just hit space, like the space bar. You can just hold it down and then it temporarily turns on your mic, right? So, all right, good talk. Oh, that's cool. I didn't know it could do that. All right. So let me show you WebAssign. So in WebAssign, so this is an actual problem from your homework. Notice how, given an equation, right, you have to find the vertex, focus, and directrix. Now, to do this, it says, see how this is not in the form that you want. So you're going to have to get all your Y's to one side, all your X's to the other side. You might have to complete the square. This is one, completing the square. You'll complete the square with the Y's, right? So you'll complete the square with the Y's on this one. Okay, but then it's going to ask you to graph. Now, graphing this is really crazy, okay? So let's do one that's easier. Let's do this one, okay? So I'm going to graph this one. So to graph this, notice how my center is going to be to the right 3/2 and up 6. Now, how the heck are you supposed to graph that? So here's the thing. Just guess, okay? And I'll show you what we're going to do. So I'm going to go to the right 3/2, and then I'm going to go up 6. So that's going to be about here. Oh, why? Oh, sorry. I have to, sorry. This is complicated. So first you have to select, is it opening up or right? So in this case, it's a Y, and I'm opening to the right. So then I'm going to go, I'm over here, and then here's my center. I'm just going to guess. Okay? Now, you don't know if that's exact. So then what you're going to do is you're just going to pick any X, and you're going to type it into your calculator and solve for Y. So you're just going to get any other point. and then you're going to put that point on here on the graph. Now, as soon as you do that, it plots this. So again, first, is it opening up or left? You have to select. Then put your vertex down, and then use your calculator to find one other point. Now remember, we just guessed. This is where you hit the double arrow button, and it says graph layers. Here, I'm going to open up my window just a little bit more. It says graph layers. I'm going to click on that, and then you can manually enter the points. So 3 halves is 1.5. 3 halves is 1.5, and then I'm up 6. So my vertex is correct now. And then you would just enter in the value that you found using a calculator. Does that make sense, guys? So you really can just put 2 random points. You just have to make sure you have the right? Either you're opening up or to the right. And then you just, how did I get here? This a little double arrow. You click on horizontal parabola like this, and you can just manually input that thing. That's the only way you're going to be able to do this, okay? You're going to have to manually input the vertex and some other point. Okay, so with that said, do you guys have any questions? Here, I'll recap everything. 1, is it opening up or down? It's opening to the right. Guess your vertex. And then get another point. You hit the double arrows. A little thing pops out. I click down, and then I can manually enter the coordinates that I got. Any questions about that? So you can see with your homework, right? You're going to have to get this to standard form, focus, vertex focus directrix, graph it, get it to conic form, vertex focus directrix, graph it, and then what else is on your homework? Like a couple that we started before. Okay? Does anybody have questions about that before I close this up? You guys are awfully quiet today. No one has questions? All right. Well, it is past 12:10.